How to Cure Type 1 Diabetes, a presentation by Professor Gershom Zaitchik, Faculty of Medicine, Hebrew University of Jerusalem. Did you ever wonder why can't we cure type 1 diabetes? The answer is simple. Current diabetes theory is false, and so are its treatments. As the proof of the pudding is in the eating, so is the proof of the theory in the treating. Unfortunately, the medical pudding is rotten. Listen why. Two theories explain the nature of type 1 diabetes mellitus. Medicine says diabetes type 1 is an autoimmune disease. It is caused by immune lymphocytes that destroy insulin-producing beta islet cells. Alternative, diabetes type 1 is a viral disease. Viruses destroy insulin-producing beta cells. The two theories propose different treatments. Medicine, diabetes type 1 is incurable. It may be alleviated by preventing immune lymphocytes to destroy beta cells. Alternative, diabetes 1 is curable. This viral disease may be cured by preventing virus infection, which is known as virus interference. Both theories are supported by the same laboratory experiment, yet interpret them differently. Both virus and lymphocytes invade the insulin-producing beta cells. Medicine says lymphocytes are the primary cause of type 1 diabetes, and virus is a passenger. Alternative, virus is the only cause of type 1 diabetes, while lymphocytes repair the damage caused by it. The role of viruses in type 1 diabetes. Two distinct cellular and molecular pathogenic mechanisms of virus-induced diabetes in animals. It's a very interesting review, and I shall discuss it in light of the two theories. They write, type 1 insulin-dependent diabetes mellitus results from the progressive loss of pancreatic beta cells. One environmental factor, the virus, has long been considered to play a part in this disease. To date, 13 different viruses have been reported to be associated with the development of type 1 diabetes in humans and in various animal models. The most clear and unequivocal evidence that a virus induces diabetes in animals comes from studies of the D variant of the encephalomyocarditis EMCD virus in mice and the Killam rat virus KRV in rats. The infection with a high titer of EMCD virus results in the development of diabetes within 3 days. This is largely due to the rapid destruction of beta cells by the virus within the beta cells. In contrast, the infection of mice with a low titer of EMCD virus results in a limited replication of the virus before the induction of neutralizing antivirus antibody and the subsequent recruitment of activated macrophages. Medicine claims that the same virus has two different pathogenic functions. The first is high titer infection destroys beta cells in 3 days, but low titer infection activates macrophages, which initiates an autoimmune destruction of beta cells. Medicine regards these two pathogenic functions as two different disease models. One model consists of mice infected with a high titer of EMCD virus in which diabetes develops as a result of the destruction of beta cells. The other model consists of mice infected with a low titer of EMCD virus in which diabetes develops by the destruction of beta cells through soluble mediators released by macrophages that the EMC virus infects and activates. Histogenesis of a virus infection reveals a different scenario. When virus infects a tissue or an islet, it destroys its beta cells by lysis. The tissue responds with inflammation. First enter granulocytes, then lymphocytes, and finally macrophages. In low titer infection, the virus continues destroying cells. Inflammation becomes chronic, dominated by macrophages. The two models of virus infection are two modes of response to cell destruction. High virus titer initiates an acute inflammation. Low virus titer initiates a chronic inflammation. And inflammation repairs damage by the virus. Yet according to medicine, there are two kinds of damage. Damage by virus, which occurs during acute infection, and damage by autoimmunity, which is initiated by macrophages and occurs in chronic infection. It is the main cause of type 1 diabetes mellitus. So here you have the scheme of autoimmune diabetes mellitus, which was taken from this paper, Infection and Autoimmunity, edited by Schoenfeld and co-workers, figure 3. And this slide summarizes the view of medicine. So here you have virus infects macrophages. Macrophages secrete various substances, activates other cells, and again these secrete, or here you see the substances are secreted by other white cells which are infected by the virus. And here you have again a virus which infects also another white cell, and they also secrete substances which cause beta cell death and diabetes mellitus. So this is the current view of medicine. Note the flaw. Here you have 3 viruses activating or infecting cells, but virus is tropic only to beta cells and not to other cells in this scheme, which means the virus does not infect these cells. It infects beta cells, and then you get this scenario according to the medicine. So what is the main message of this scheme is that type 1 diabetes is incurable. treatment consists only of reducing autoimmune destruction of beta cells by eliminating white cells in this scheme. So, if you manipulate these cells, you can get a remission of type 1 diabetes medicine, but you cannot cure it. But the alternative theory says the opposite, that it regards type 1 diabetes as viral disease, and these cells repair the damage caused by virus. So the alternative says you have a virus, it destructs beta cells, and they activate the whole thing. What you see here is inflammation, but this is a repair to the damage caused by the virus. When a tissue is infiltrated by non-tissue cells, it is regarded as tissue pathology. There are two ways to explain the cause of the tissue pathology. Entering cells are response to an external cause, and entering cells are the cause. So here you have a healthy tissue which is transformed into a pathology, and you know that it is pathology because you see the white cells. And then you say, are the white cells themselves causing this pathology, or are these white cells a response to an external cause? This view was already discussed in the 19th century. Rudolf Virchow, the great pathologist, maintained that disease originates in host cells. He observed anthrax bacilli in macrophages and concluded that macrophages distribute them and therefore ought to be eliminated. Had he lived today, he might have used for this purpose steroids or chemotherapy. Then came Eli Mechnikov and revealed that the true nature of the macrophages. They swallowed anthrax bacilli in order to eliminate them. And then Robert Koch defined his postulates, and white cells became our defenders against microbes. So, which means that these cells enter the tissue as defenders and not as cause. Unfortunately, Koch's postulates failed when trying to prove that viruses cause a tissue pathology like type 1 diabetes. And medicine adopted Virchow blames the macrophages explanation, which is known as autoimmunity, and medicine says that this autoimmunity causes diabetes type 1 mellitus. While autoimmune diabetes is incurable, EMCD-induced type 1 diabetes may be cured. And let's return to the paper which I mentioned earlier by Yoon and Yoon, and they write, viruses can also prevent diabetes. Lymphocytic choriomeningitis virus, LCMV, can prevent the development of autoimmune type 1 diabetes in biobreeding rat. There are two stable variants, one highly diabetogenic, EMCD, which produces diabetes in over 90% of infected animals, and the other non-diabetogenic, EMCB, which does not produce diabetes in any of the animals it infects. So these are viruses which look alike, each one has a different function. The two variants could not, however, be distinguished antigenically. Examination of the complete nucleotide sequences of the genomes of both variants showed a total of 14 nucleotide differences between them. This was the only difference between a diabetogenic and non-diabetogenic virus. I discussed virus interference in several presentations, like interference between viruses during cancer and virus interference and oncolysis. And here is also an important review on this subject, interference phenomena between animal viruses. Now I shall explain how you apply these ideas to our current discussion. In the paper on interference he writes, "It is well known effect that infection of a bacterium, plant or animal with one virus frequently prevents or partially inhibits simultaneous propagation of another viral agent in the same host. It is the aim of this review to analyze interference as it occurs mainly between various animal viruses." So here is an example how you induce interference with our EMC viruses. EMCB is a non-diabetogenic virus. Its infection might protect mice against the diabetogenic EMCD. The two variants can not be distinguished antigenally. So you treat EMCD diabetes with EMCB virus, and this is the essence of virus interference. I shall explain now the kinetics of interference between the two viruses. Tissues consist of tissue proliferative units, TPUs. Beta cells belong to a tissue proliferative unit in the pancreas. TPU consists of two compartments. Stem cell at tissue origin divides and its progeny streams through the unit, differentiating as they go. When young, they proliferate. Later on, they differentiate and finally die at TPU periphery. So here you have the standard cell kinetic structure of any tissue unit, and the same applies to beta cells. You have a stem cell which produces beta cell progenitors, and they divide and become and differentiate into beta cells which do not divide, and finally the beta cells die and they are replaced by new beta cells. This is a normal turnover of the beta cell proliferative unit. Stem cell of this unit is in the intercalated duct of the excretory pancreas. So what the MCD virus destroys mainly end cells, since progenitor lacks receptor for the virus. So here you see the destruction by the MCD is only differentiated beta cells because they have the receptor to accept the virus. Progenitors generally do not have the receptor, and therefore you get less beta cell and you get diabetes. This is called MCD lysis. Progenitors continually supply healthy cells. Since both viruses compete for the same receptors, less beta cells are destroyed and progenitors may restore the Q compartment. So now you have a diabetic mouse and you treat it. So you treat it with the MCV virus. So the diabetic mouse is infected by the MCD. Both viruses compete for the receptor of the beta cells. These cells don't have receptor generally, and therefore they are not affected by the virus, or they are less affected by the MCD virus. So this is the treatment. They compete for the same receptor. Less beta cells are destroyed, and the progenitor can replace those destroyed beta cells. This is the essence of interference treatment. I describe this treatment in order to explain what interference is. However, it is not optimal since MCV infection is lytic to non-beta cells. The solution is to infect the unit with a non-lytic virus, and I describe it in the presentation, interference between viruses during cancer. So here you have the diabetic unit, which is infected by the MCD. In order to treat it, you need a non-lytic virus, which is a virus which infects the cell once and does not replicate in the cell, and this non-lytic virus may protect the unit, partially obviously, against MCD. And this is the essence of the treatment. Conclusion. I firmly believe that virus interference might cure type 1 diabetes.